Hi friends, this is Naresh. In this class I am going to explain about centroid of an Z and I sections and how to locate the center of gravity of these sections. This is my fifth class on centroids. Now first of all you have to know the centroid of a rectangle. The centroid of a rectangle lies at half of the base and half of the height. So by using this principle, now look at the problem. Question is here: locate the center of gravity CG of the given Z section. Now the given dimensions and figure are shown in here. Z section, already we have know that Z section is a unsymmetrical plane. So you have to find the values of x and y. Now first of all, the given Z section is split up into three rectangles. First one is a bottom rectangle, second one is a vertical rectangle, and third one is top rectangle. Now first one, the dimensions of a bottom rectangle are base B1 equal 100 mm and depth D1 equal to 20 mm, where B refers base of a rectangle, D refers depth or height of a rectangle. So therefore for bottom rectangle, height 20 mm and base length 100 mm. Now vertical rectangle dimensions are base 2 equal to 20 mm. So here base 2 equal to 20 mm, so B2 equal to 20 mm. Now height or depth D2 equal to 60 mm, where the total height from here to here 80 mm. So now I am considering the height of a vertical rectangle only, D2 equal to 60 mm. Now the dimensions of a third rectangle are height D3, depth or height D3 equal to 10 mm and base B3 equal to 120 mm. So here now I am considering the reference axis, that is the x-axis at the bottom edge and y-axis at the left side edge. O is the origin. Now I am going to locate the individual centroids of an Z section. Here A1 is the area of a bottom rectangle. A1 equal to base into depth, so A1 equal to B1 into D1 equal to 100 by 20. So base 100 and height 20, so 100 by 20 equal to 2000 mm square. And second rectangle, A2 is the area of a second rectangle, so A2 equal to base B2 into depth D2. So therefore A2 equal to B2 into D2 equal to 20 by 60 equal to 1200 mm square. Now I am considering the third rectangle, base B3 equal to 120 mm, D3 equal to 10 mm. So the area of a third rectangle A3 equal to B3 into D3 equal to 120 by 10 equal to 1200 mm square. Now x-axis, now I am considering the x-axis at the bottom section. and y-axis at the left side edge. Now I am drawing the diagonal lines to locate the individual centroids, where C1 is the centroid of an bottom rectangle C1 at a distance of x1. x1 equal to gap 100 mm plus base b1 by 2. So x1 equal to 100 plus base b1 by 2. So x1 equal to, next y1 equal to height d1 by 2. Similar way, now I am drawing the diagonal lines for second rectangle. C2 is the centroid of a second rectangle at a distance of x2. x2 equal to gap 100 mm plus base 2 by 2 from y-axis. Similarly, at a distance of y2 from x-axis, y2 equal to d1 plus d2 by 2. So therefore y2 equal to d1 plus d2 by 2. In similar manner, I am drawing the diagonals for C3. C3 is the centroid of a third rectangle at a distance of x3. x3, this is the, from here to here, x3. x3 equal to base 3 by 2. So base 3 by 2, half of the rectangle. In same way, y3 equal to d1 plus d2 plus d3 by 2. So total value y3. So from figure, x1 equal to 150 mm, x2 equal to 110 mm, x3 equal to 60 mm. y1 equal to 10 mm, y2 equal to 50 mm, y3 equal to 85 mm. Now these values are written in tabular form in next slide. So here I am showing the section number 1 to 3, type of plane, bottom rectangle, that is bottom flange, web and top flange. Dimensions of a bottom rectangle, these are the dimensions of a middle rectangle, these are the dimensions of a top rectangle. Area, individual areas a1, a2, a3, and individual centroids x1, x2, x3, y1, y2, y3. From general expression, xc equal to the distance of centroid or center of gravity from y-axis, and yc is the distance of centroid or center of gravity from x axis. Now xc equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. By substituting the values, we will get the answer xc equal to 114.54 mm. In similar way, yc equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Now yc equal to 41.36 mm. These are the final answers. Now in next slide, I am showing the final position of a centroid for Z section. For locating the centroid or center of gravity of the Z section, first you have to know the individual centroids, that is C1, C2 and C3. Now C1 is the centroid of a bottom rectangle, C2 is the centroid of a middle rectangle, C3 is the centroid of a top rectangle, whereas CZ is the centroid of an Z section. So CZ is the centroid of an entire section at a distance of xc equal to 114.54 mm from y-axis, and yc equal to 41.3 mm from x-axis. This is the final position of a center of gravity of an Z section. This is the final answer. Now look at the second problem. Question is locate the center of gravity of the given I section. In given figure, it consists of an I section. It consists of an I section and top cover plate. So first of all, the given figure is converted into four rectangles. Four I am showing here. First one, B1 equal to base B1 equal to 100 mm and D1 equal to 20 mm. So this is the first rectangle, and the second rectangle is base 2 equal to 20 mm. This is base 2, and D2 depth D2 equal to 60 mm. In similar way, the third section is base 3 equal to D3 depth D3 equal to 10 mm and base B3 equal to 120 mm. And finally, the fourth section is top cover plate, and dimensions are base B4 equal to 150 mm and depth D4 equal to 20 mm. So for locating the centroid CZ, you have to consider the reference axis. Now I am drawing the x-axis at the bottom edge and vertical y-axis at a middle section. The given I section is symmetric about y-axis. So therefore the values of x are 0 because the given section is symmetric about y-axis. Therefore the centroid lies on y-axis only. There is no need to find the values of x, x1, x2, x3, x4. Now I am locating the individual centroids. Okay, A1 is the area of a bottom rectangle, that is B1 into D1 equal to 2000 mm square, and A2 is the area of a second rectangle, that is B2 into D2 equal to 1200 mm square, and A3 is the area of a third rectangle, that is B3 into D3, so 120 by 10 equal to 1200 mm square, and A4 is the area of a top rectangle, that is A4 equal to B4 into D4 B4 into D4 B4 into D4, that is 3000 mm square. Now I am drawing the diagonal lines to locate the individual centroids. O is the origin. So here C1 is the centroid of a bottom rectangle at a distance of y1 from x-axis, that is y1 equal to d1 by 2. In similar way, I am drawing the diagonals for second rectangle. C2 is the centroid of a second rectangle at a distance of y2 from x-axis, that is y2 equal to d1 height of a bottom rectangle plus half of the second rectangle. So y2 equal to d1 plus d2 by 2. In similar way, for third section, C3 is the centroid of a third rectangle at a distance of y3 from x-axis. So y3 equal to height of a bottom rectangle plus second rectangle plus half of the third rectangle. So y3 equal to d1 plus d2 plus d3 by 2. And C4 is the centroid of a fourth section. It is at a distance of y4 from x-axis. So y4 equal to height of a bottom rectangle plus vertical rectangle plus third rectangle plus half of the fourth rectangle. So y4 equal to d1 plus d2 plus d3 plus d4 by 2. It is symmetric about y-axis. Therefore x1 equal to 0, x2 equal to 0, x3 equal to 0, x4 equal to 0. And y1 equal to, from figure, y1 equal to 10 mm, y2 equal to 50 mm, y3 equal to 85, y4 equal to 100 mm. Now all these values are written in tabular form. Now here you can see section number, plane type, dimensions, area, x values and y values. From general expression, x equal to the distance of centroid or center of gravity from y-axis, and y equal to the distance of centroid or center of gravity from x-axis. X equal to a1 x1 plus a2 x2 plus a3 x3 plus a4 x4 by a1 plus a2 plus a3 plus a4. So the final answer is x equal to 0. In similar way, yc equal to a1 y1 plus a2 y2 plus a3 y3 plus a4 y4 by a1 plus a2 plus a3 plus a4. That is yc equal to 65.135. Now I am showing the position of a centroid, where C1 is the centroid of a bottom rectangle, C2 is the centroid of a vertical rectangle, C3 is the centroid of a third rectangle, C4 is the centroid of a top rectangle. So C1, C2, C3, C4 are the individual centroids, whereas CG is the centroid of an entire section. So the center of gravity or centroid CG at a distance of yc equal to 65.135 mm from x-axis. So x equal to 0 and yc equal to 65.135. So these are the final values, and the final position of a center of gravity is here. This is the final answer. Okay, thank you.